Warm greetings again. So now we are going to see about training neural networks with the continuation of and the characteristics of perceptron. In neural networks is a simple perceptron. So already we discussed a simple nucleus that has been treated as a mechanical kind of perceptron, or a much more complicated multi-layer network with special activation functions. So we have to go with that systematic procedure for determining appropriate connection weights. The network learn the appropriate weights from a representative set of the training data. So already we know we are having that two setup of the data. One is called trained data and another one is called that is the testing data. Already we discussed these parameters at that earlier. So in the neural networks we have to learn the neural networks with the appropriate weights from the representative set of that training data. So that is a very important parameter that's happening in the neural networks. So every neural networks must learn that appropriate parameters through by the weights. That weights should be representative set of that training data. In the simplest cases, however, the direct computation of the weights are unmanageable, so that is not possible. So we have to give appropriate parameters for each and every weight. But in real neurons, so that is that possible, because that intelligence that has been created by that supernatural power. But when we are implementing the same activity of the neurons into that machine, it's having little bit of complexity. So the direct computation of the weights are really unmanageable one. A good process is the start off with that random initial weights. So we have to train the data sets with that little bit of random initial weights and adjust these weights according to the steps and according to the required outputs that has been needed. So we have to be initiated with that one random weights, and we have to be lookout for that output, and according to that output we have to be retuned or the rearrange, that is the initial weights. Now we have to see a perceptron introduction. A perceptron is a neural network unit. It's having that certain computations to detect that the features or the business intelligence in the input data. So a perceptron is an algorithm for supervised learning of the binary classifier. So already we said that this perceptron is working on the concepts of that binary classification method, and there we can able to use the logical components already we learned. It may be either in that AND gate operator, or it may be that OR operator, or it may be that exclusive OR operator. So depending upon the situation, you are having the choice to select the appropriate logical components for your perceptron. So the perceptron algorithm that comes under the category of the supervised learning. So this algorithm enables the neurons to learn and process the elements in the training set one at a time. So already I said this an example several times, how the baby is learning to say the first word of mom and dad. The same way we have to train the system according to the weights. Just we have to train the neurons and the process of that elements in the training on that one time. So in that baby also we have to ask that baby to say one word a day, or that one word for a couple of days. So on these days the baby will learn these words and try to reproduce the same word what that mom is teaching to her child. A single artificial neurons that computes its weighted input and uses a threshold activation function. And continually we have to see that the schematic representation of that perceptron. So we are having that several inputs that may varying from 1, x1, x2 up to that xm. For that each input we have to be assigned the random weights. Already we discussed how we have to be assigned that random weights. Until we have to reach that appropriate output, the algorithm can able to give the privilege to adjust the weights according to reach that appropriate output. So we are having that is the weights W0 up to the Wm according for the inputs, and we are having that net input function, it is called, that is that sigma, and we are having that activation function. So on consecutive slides we have to see what are all the types of that activation function is there, and we have to produce that is a appropriate output for that perceptron. So this is the concepts that's happening in that perceptron simple architecture. On the continuation we have to see about the types of that perceptron in that next parameter.